Welcome, code aficionados and digital daredevils, to a podcast that's about to dive deep into the fascinating world of WebAssembly. WebAssembly, or WASM for the initiated, is revolutionizing modern engineering, pushing the boundaries of what developers can do. It's like a secret portal connecting your code to the digital cosmos. On this show, Ep5 hosts will be your guides to this virtual dimension, decoding the mysteries and unveiling the endless possibilities. So strap in for a special bite-sized adventure as we take off with WebAssembly Unleashed.
All right. Thank you, Tabitha. Once again, welcome to WebAssembly Unleashed. I'm your host, Joel Moses. Alongside me, of course, is Oscar Spencer, my partner in all things WebAssembly. And we are pleased to actually welcome a special guest today as we're sitting together at a table, face-to-face, talking with each other. That's fantastic. It's nice to see you not in a box, Oscar. At Ep5 App World. Oscar and I, of course, both work for Ep5, as does our guest here, Dr. Gilad Bracha. And we thought we'd have an interesting chat today. Let me explain the context of the chat. And I'm going to let Gilad do a lot of the talking about his history because, of course, he knows it better than anybody else. Although I will point out that he has a Wikipedia page, making him one of the rare Ep5 Nginxers that has a Wikipedia page. And on that page, I want to...
I'm an Nginxer, Joel.
That you are, yes.
I am?
You are. We're all Nginxers.
Oh, I didn't know that.
All of us are.
Because
yes.
I never contributed anything to it.
So among his many qualifications for being here and talking with us today, he was the 2017 recipient of the Nygaard Prize, which is for luminaries in the programming field. And he has a long and storied history, starting with, of course, where you came from, which is work on Smalltalk. And that led you somewhere, didn't it?
Right. So in ancient times, in early to mid-90s, I worked at a startup that was developing a high-performance Smalltalk engine and also a type system for Smalltalk and an IDE and the whole shebang. And it got acquired by Sun because circumstances forced us to start working on a Java virtual machine as well. That's the shortest possible way to put it.
Okay.
And that became the hotspot virtual machine.
And that, of course, was the early days of the Java specification, where the concept was highfalutin and it promised a whole lot. But then you started working on it, and tell us about that experience.
Well, it looked best before I started working on it. like most things, to be honest, right? Familiarity breeds contempt, especially on fertile soil like me, where contempt grows naturally. And so it very quickly became clear that there were a number of issues that weren't really being handled properly technically, partly because of the weird governance structure that was going on there, partly because it was too complicated to begin with. So there were, I didn't know what I would do there when they acquired us, right?
Right.
My passion is for development environments, and I said, we should have a real cool, really live interactive development environment for Java, just like we have for Smalltalk. And they said, no, we don't do that. Our partners do that. We have a Chinese wall.
We don't do that.
They don't do that. That's literally what they said. Chinese wall is what they said, literally, between us and our partners. We just do the core system, and others will do this. They eventually changed their mind when they realized how important this was, but it took them years and years, and they never built anything remotely similar to what I had wanted, of course. But that was, so I didn't know what I would do there. Well, that's what I do, and I stumbled into this work on the spec more or less by accident, because one Friday afternoon, it's always a Friday afternoon.
It's always a Friday. Yeah.
There was some problem with some telco had escalated this for up to, it got to me on Friday afternoon, that they had some huge problem with class loaders and things, and they couldn't, and they gave us a directory with 30 subdirectories and a giant pile of stuff, and this doesn't work, and see if you can look into it. Now, the only way to solve this in a reasonable way is you happen to be more or less one of the maybe 2-3 people on Earth at the time who knew both class loaders and the Java verifier, because it turned out to be this bizarre interaction And I could never have sorted out from the stuff they gave me. You actually, this is one of those classic things you have to sit back and think about it.
Right.
Not a common, don't do this at home, kids, you know. But, and then when I came back like 2 hours later and said, this is what's wrong, you know, they thought I was smart or something. You know, you can get off quite far by tricking people that way. And so, and then it said, well, you know, actually we have a lot of bugs and complaints with respect to the specification and stuff. Maybe you should kind of handle that.
Oh.
And it turned out that this was this ongoing, like, it's not a pleasant metaphor, but I like unpleasant metaphors. It was like this, you know, you're by this river after some terrible war, and there's these dead bodies floating by, and you have to diagnose and do postmortems on them. It was, for years, endless problems because it was too complicated. There were there still are certain fundamental errors in my mind of how this was done. And there's no end to it. It was just, no one could keep this. My job was to keep this specification in my head full time. So I could just manage that. No one who wasn't doing it absolutely as their full-time job could ever follow this in enough detail to really know. The book, it had contradictions inside it that, you know, there was, so it was fun work.
Sifting through the bodies in the river was
fun
work.
It's fun work. I just have to casually keep this entire Java specification in my head. And that's fine. That's the normal thing that everyday people can do.
Well, if they pay you, yes.
Pay you.
And that is the
wouldn't
dream
do it
for a
voluntarily.
compiler
That is
engineer.
definitely the dream, right?
dream.
Yeah.
Yeah, no, it wasn't a bad job for a while. I did this for almost 10 years, but I couldn't. In the end, it's like the trauma was too much.
Right. So here you are in control of this specification. Okay.
Control.
Control is maybe a hard word in this.
Sure.
Here you are possessing this specification and charged with caretaking it. And I think especially for Java in its early days, the specification, it was one thing, and also the promise of the technology was another thing.
Yeah.
It promised to be write once, run anywhere.
Yeah.
It
So,
promised to be security boundaries. It promised all sorts of things.
yeah, so I'd love to just get into the meat of that because I know everyone watching has this exact question. Java made that promise of write once, run anywhere. And had varying degrees of success, I'll say with that. And WebAssembly now says, hey, we're going to do exactly that. We're going to do write once, run anywhere, but we're going to have some different ideas about it, and we're going to try and make it far more universal. Do you think that there's any chance that'll be true for WebAssembly?
There's a chance. There's always a chance. But no, I think there is a chance because in the end, it is a much simpler and smaller system you're dealing with. So programming language, there's one thing to say that the programming language has clear, is well standardized. And even that, it's written an English language specification. There's endless ambiguities, which was part of the problem. And so that way, the smaller your thing is, then there were libraries. There were all kinds of interactions with, in a language, in an object-oriented language, typically there are magical libraries that have superpowers, like reflection and class object and class. And all these things brought opportunities for interpreting things differently, for not wanting to do them a certain way. In certain ways, Java was also quite new to most of the people working on it and implementing it, and they didn't really understand what this was supposed to be. And so there was just too much leeway. Certain things were just under pressure of time, right? This was a commercial enterprise. So there's, to take like a concrete example out of many, there's like system.out and system.in, right, in Java. Right, so in a language designed for security, why would you make your input and output streams public mutable variables? And the reason is that originally it wasn't designed for security. It was supposed to run internally on a cable TV network, was probably the original. And then someone discovered that, we can put it on the apply it to the internet, and then we'll tell people, and the verifier was a late development as well because of that. Oh, we can check it because
Right.
there is a security concern. And in the end, Java's great opportunity was at one point not Netflix, Netscape. Oh, sorry, the net has changed over the years. That was a Freudian. But Netscape, right, the original web browser, they said they'd use Java, and this was the golden opportunity. This is like the big time. I mean, Java, you have to remember, Java was a project that had failed multiple times before it hit the big time. And so, in the end, they had 2 months to make this ready to ship, when they had no plans of actually having it ready to ship at all. And so in this mad scramble, no one had the time to sort out, like, for example, these variables. And eventually this was an example of a security hole. And, that's the kind of situation where if you're doing this, WebAssembly has been going on for a long time at a relatively deliberate pace. I'm sure some people think it's too deliberate, but that gives you the opportunity to nail it down before there's like this kind of commercial pressure and time pressure. That also helps. And it's smaller, and there's an attempt to make it more systematic and rigorous, I think. So there's a chance, yeah.
So it sounds to me, so there's a few things at the root here. One is there wasn't a very deliberate pace in how Java was developed and pushed out to the world. It was start, stop, and panic in some cases. So moving it into the browser space was done perhaps maybe a little too quickly and not as deliberately as it should have been, which introduced security problems. So maybe deliberate pace is a lesson that WASM can learn from this. It also has something to do with the runtime, the battle for the runtime, right? So Java, of course, famously based on runtime architecture, and a lot of different implementations emerged, and strikingly enough, some of them were from Sun.
Sure. You want to get into that?
Oh, why not?
So there were, within Sun, there were multiple implementations, and there was sort of a political battle as to what would happen. So we got acquired and say, we love your technology, you're going to be the next VM, whatever. And then we discovered that there was another project building a VM, and that actually this wasn't quite as decided as we might hope. So I don't think that necessarily, of course, whenever you have multiple implementations, there's scope for differences. So I don't think that was the biggest problem, but certainly there was that. There was the whole idea is that we were making something that we were going to allow other people to implement to a specification, yet we weren't. There was this battle between church and state, as they called it, right?
Okay.
So there was the public story that we are putting this out for everyone, the church, right? This is so everyone can use, and and it'll be the standard, and you can use our patents and all that. And then there was the people who kept, there was internal pressure in the company. We have to find a business strategy for this. This has to be fun, because this was a huge organization. The core Java language was a fairly small team of really a handful of VM engineers and compiler, and one front-end compiler engineer, Mr. Javasy. There were a series of people who were Mr. Javasy. And it wasn't very much, actually. People thought there were, but around it there was army of people doing Java beans and all kinds of stuff. And there was pressure to find a way to commercialize it. And these things were in conflict. And trying to keep it to not break people was also a huge problem.
Yeah.
Yeah, that's certainly something with WebAssembly. We had the initial WebAssembly 1.0, which was fairly limited. I know one of the design goals for it where, from the beginning, they were thinking about security, they were thinking about portability, so those are good things. But they kept the instruction set fairly small. They said, hey, we're not going to include a ton of things that you would maybe expect. So, for example, bulk memory operations, just copying one region of memory to another. That was something that was not in WebAssembly 1.0. And you would think, oh, that's something that people want to do often, right? So they deliberately kept it super small. And now we're going through this deliberate process to introduce a lot of these nice to haves, back into the system. and trying to make sure they still adhere to all the security things that we want to have and things like that. And so it's pretty interesting that it sounds like it is a wildly different approach than the way that Java really came to be.
Well, Java, as Frank Gillen once told me, this thing was never really designed; it grew. And so
like an organism.
Yeah, I mean, it because it went through several iterations, right? It was supposed to be a personal assistant, and then it was supposed to be a cable TV network, and it went through these multiple lives, which in ordinary circumstances would have, every one of those things that didn't work out should have assured its death, but yet it managed to survive till it finally hit the big time. And when you said should have been a more deliberate pace, that depends how you look at it. No, deliberate pace, it would have gone nowhere. It would have failed again, right? You basically don't have that choice.
Okay.
But there were just things that were done wrong. Keeping it simple, keeping it limited is good, but this thing had to work, and it was under different kinds of pressures, I think.
I see.
And you just can't afford to. It's hard. You can do it if you're really, really good. If you have a really brilliant, elegant, simple design, you're in better shape.
Right.
So WebAssembly is this approach to a structured assembly language. This is something we had realized that, the Java bytecode was not particularly suited to purpose eventually. And it would have been nice to have such a structure, but there's no way to do that after the fact, right?
Right.
So there's a lot of things that you can do if you try and keep things simple and uniform, that you can get a lot more leverage with a lot less work and have better control. But many of those things were not understood by a lot of the people working on it.
Right. Now, I asked that runtime question with an ulterior motive, because obviously this is something I'm a little concerned about. There were multiple runtimes, and some of them fought with each other politically, and they were implementing the same specification, but they did so sometimes in different ways and for different reasons. And obviously, in WASI Preview 2, one of the gating factors for release was we have to have multiple implementations of the runtime. That's done as a matter of process, and it to my mind, it looks to improve the quality of the product and the standard as released. But do you have any concerns about political fights between runtime operators, runtime owners?
So maybe a little bit earlier than now, there was a lot more, I'll say, infighting between runtimes to see, who's going to emerge as, the clear winner that everyone, wants to use. But I think now at this point, we have so many different runtimes that are all trying to be deliberately different in some way, right? You have WASM Edge, which is we're going to be really good at deploying WebAssembly at the edge, right? You have WASM 3, which is we're not going to do any ahead of time compilation. We're not going to do any jitting. It's just going to be a super fast interpreter, and it's for places where you don't want that behavior. You just want it to be as small as possible and run. Then you have projects like Whammer, the WebAssembly micro runtime, which is I want to run WebAssembly on really tiny devices. That's going to be probably a very different runtime than some of the other ones that you're going to run. So I think because we have all these different runtimes that are trying to be deliberately different for specific use cases, it's avoiding a lot of the political stuff that we normally see.
So Gilad, hearing that, are there any shadows that you see on the horizon?
So I'm not following these projects close enough to say anything specific about them, but they have very different needs, and that tends to creep up and say, oh, you specified that this should do that, but really this is awfully inconvenient and we're not doing that, and you get into a whole set of problems perhaps that way.
Inconvenience.
Yeah, a really good example of this, something that we talked about in the WebAssembly community group recently was there's a need, or I should say a want, to add a bunch of float 16 operations to SIMD. Same instruction, multiple data, do a bunch of math at the same time. And one of the things about it is, hey, how do you actually implement this on different platforms? Because one of the things that you can't do is just do operations as float 32s and then cast them down because of the different precisions. And so depending on the runtime and how they implement it, you're going to get different results. Right. So are we going to allow non-determinism, for example, right? Are we going to say it's okay that different runtimes have different answers for these things, which typically, that's not something we want.
For disaster.
Once you do that, run once, run anywhere
Yes.
disappears.
The thing was write once, debug everywhere. Was
Right.
The actual,
Okay.
And this
Yeah.
is exactly the kind of thing. Literally, these they're numeric issues. There's less issues because WebAssembly, you don't have a reflection API. There's all kinds of things that building a complete platform beyond just the core language and a high-level language with more semantics and actually narrower application in some sense makes that worse, but you still have that problem.
And now that you're sort of talking about that, one of the early complaints by language implementers and even runtime implementers is WebAssembly has absolutely zero stack introspection. So the WebAssembly bytecode operates as though it's running on a stack machine. You put things onto the stack. You use instructions to pop things off of the stack. You cannot look at the stack and see what's on it, which that doesn't sound like a huge problem. But let's say you want to write something like a garbage collector. All of a sudden, it would be fantastic if you could look at what was on the stack and see pointer addresses pointing into memory, so you could go and say, hey, there are objects here that I know are live and I shouldn't throw in the trash just yet, and things like that. So the way folks have gotten around this at this point is a lot of languages implement a shadow stack where they manage a whole separate representation of everything that is currently on the WebAssembly stack, which that's kind of wasteful if you think about it, right?
Is.
And so that's one of the huge complaints. But I'm very curious, what are some of your ideas? What complaints do you have about?
So this touches on some of my complaints, as I'm sure you know, right? So generally, writing I haven't used WebAssembly as such. I have a tool chain that one of my colleagues did where we take a VM for a language I've worked on called Newspeak, which is written in C++ and through mscripting and stuff, runs WebAssembly, runs in a browser. That's all great, but performance for an interpreter has been very disappointing. No comparison to this, and that's probably because of a bunch of these kinds of issues. That's one thing. The other thing is, of course, you have to write your own garbage collector. So now there's a garbage collector. You think the problem is solved. No, it isn't solved, because it's all fine if your garbage is very vanilla, garbage collector is very vanilla. And for interesting languages, that isn't true, because one of my passions and one of the things I wanted to do for Java and we never could do because people didn't grasp it then, they don't grasp it now, is the advantage of live systems where you can actually modify things dynamically, right? It's reflection on steroids. It's not just introspection, but the ability to actually manipulate your program live, as in Lisp, as in Smalltalk. This is fantastic for the development experience. There's also really cool tricks you can do sometimes for applications.
Right.
And this is not something you, basically, in Smalltalk, right, to give people the idea, you can edit a class at runtime. You can add fields to the class. And all the instances that are still in the heap will be reshaped automatically for you, right? And so you can develop your program and you don't have to go and restart everything and get to this particular state you were in to see if the bug worked, right? There's a lot of things like that. And yes, stack introspection and manipulating the stack and changing things, writing a debugger in the system, all that kind of stuff. So how do you do that? There are a few things. There's actually only a couple of things you need that the garbage collection and memory mechanism is in perfect position to do for you. One is I should be able to find all instances of a given class or whatever prototype, right? And you can't do that in JavaScript. You can't do it in anything except some of the Lisp systems and in Smalltalk, right? And that gives them their ability to do all kinds of interesting things. Another thing is there's this wonderful primitive that I've written about that Smalltalk had that let you basically magically make swap two objects with each other. So everybody who points at object A now points at object B. So if you have, that's how the reshaping actually works. You allocate new objects with a new shape, you copy the existing fields, and then you make everyone point at that, and that's done essentially as part of a sweep like the garbage collection, right? And that enables all this stuff. And there's no way either you have this or you don't. Well, there's no efficient way to do it otherwise. And it's hard to get people to appreciate what you can do. And it's a self-fulfilling prophecy, right? Because you can't do it, so nobody uses it. So people say, well, nobody uses it. We don't have to put it in, right? And you don't make progress.
Yeah, it's certainly difficult because for those of you that have been following along with the WASM GC proposal, one of the things that you'll notice very quickly when you read the proposal is it doesn't actually implement a garbage collector. In fact, it almost, depending on how you look at it, it almost has nothing to do with garbage collection. All it is it allows you to define structures that are going to go on a heap such that a host runtime would be able to implement a garbage collector for you.
A hook for a collector, not a collector in itself.
Almost not even a hook. I think if it were more of a hook, that would at least help solve some of the things, Gilad is talking about here.
Yeah.
It truly is I'm just not going to have linear memory. I'm just going to say I'm allocating objects and you do it for me, right?
Got it.
And I don't have the option to say, I want, half of this to be linear and half of it to be GC unless they're completely separate memories, right? So that's a thing to, consider. And certainly things that were definitely considered in going through the idea of the GC proposal. But why did we end up where we are today? It's because, hey, let's get something that works.
Let's do it quick.
Let's do it quickly. Let's get something that works. And let's leave it up to runtimes to decide how they want to implement the GC instead of leaving it up to languages to decide how they want to implement the GC. So you'll have a trade-off. There'll be some languages that say, hey, we're going to ship our own GC. So when you compile your WASM module for a particular language, it's going to include the full garbage collector in there. You have languages like mine that say, hey, we wrote this, technically not GC, but we use a reference counting algorithm. I want to throw that in the trash. I hate it. I hate debugging it. It's horrible. And so we probably will use WASM GC because it's so much easier for us, right? But it does limit you in a lot of the things that you could do. But of course, there's always opportunities to continue advancing and changing the standards.
So Gilad, I'm going to give you a question that I'm sure will be rather difficult for you to answer, knowing what views that you hold about your former work. But is there something that you can point out to the WASM community that Java did right that it should continue with?
Well, so Java did do some things right, but WASM, you're dealing with an assembly language. So what did the Java bytecode do right? Eventually invoke dynamic, right? Eventually there's something that is actually a general enough hook that really gets beyond the built-in semantics that you had that lets people do interesting stuff. That's actually an example at the bytecode level of something that worked very well. And that, might, that doesn't translate into a concrete proposal because who knows what that is and where you need it, but that is an example of something that was done well.
And what advice would you give to people out there, young people who are perhaps interested in getting into the standards community, getting into language design and compiler design? What would you say to them?
You don't want me to say don't, right? So, you have to have a passion for this stuff, in which case you will do it anyway, and it may ruin your life or not. It's also, I don't know if this is the right moment in history to do that. I think with all that's happening now with AI and stuff, we still need runtimes. We still need, if you have a head for low-level stuff for systems thing, that's fine. We need that. Language design, it turns out the AIs still benefit from good language design because the abstractions help them too, but I'm not sure how long the window for that is. But then I'm not sure how long the window for anything is these days. So I'm not sure I have advice. Just, don't do it.
Well, I guess it's about time for us to wrap up. Until such time as Oscar and myself are replaced by artificial intelligence derivatives that implement us exactly, we remain your hosts. Gilad, I want to thank you for being with us.
Thank you for having me.
It's really a joy to talk to someone who's got such a a background in the things that we're all passionate about.
And absolutely, still inspiring for us young compiler engineers, despite, the life-ruining circumstances.
Until we all disappear. Right?
I hope my cheery disposition helps you.
Well, with that, thank you, Oscar. Thank you, Gilad. And as always, I'm Joel Moses. You've watched WebAssembly Unleashed. Make sure to stay with us, and we'll have another episode at you really soon. Thank you.
That's a wrap for our WebAssembly adventure, fellow code explorers. Thanks for joining us, and until next time, may WASM be with you.